If you click this video away, then please tell me what the reason for it was so that I can improve. Otherwise, hi and welcome. I'm trying to learn electrical engineering today, Fleming's right-hand rule for generators. And after we've done that, we're gonna do standing yoga. And if you participate in the standing yoga, then it's better to ask. Fleming's right-hand rule for generators. Imagine a wire passing downwards through a gap between two magnetic poles. The question we need to answer is this: will the induced current flow towards us, out of the paper, or away from us? So we're having two magnets, and between these two magnets there's a little gap, and there's a wire through it. Now the question is, will the current there induced flow up or down? The answer is that the current will flow towards us, and this fact is established by using Fleming's right-hand rule for generators. We use the thumb, first finger and second finger of the right hand, each at right angles to the other two, like three edges coming from a corner of a tree. These relate the three directions, both of the motion, the current and the field. Your teacher might explain to you how you can arrive at this answer by using Lenz's law, mentioned earlier, but the argument is rather involved. Fleming's rule is easy to remember and to apply to any generator. If you look back to figure 40 and apply the rule, you will find that at the instant in question, the generated current is flowing from the nearer slip ring. So we use the thumb, the first finger and the second finger of the right hand, okay. Each at right angles to the other two. Having a little graph here. So right hand and the other one, like that. And we relate the three directions also of the motion, the current and the field. So the thumb is the motion. And then the index finger is the field direction, and the second finger is the current direction. Commutation. Sometimes a generator is required to produce an electric current which flows only in one direction, so-called a direct current. For example, such a direct current is needed for electroplating. The rotating coil is connected to a slip ring commutator as shown, so that each of the two brushes is connected to the first one side of the coil and then the other. I still don't know what a brush is or a coil. So the rotating coil, that is the whole thing which is rotating here in the middle of that graph. The rotating coil is connected to a split ring. It must be the thing from the end, but I don't know what it is or what it does. Split ring commutator is shown so that each of the two brushes is connected to first one side of the coil and then the other. You should apply Fleming's right-hand rule to the generator shown to ascertain which is the north pole. It is in fact the right-hand one. Such a commutator used on a single coil will produce a series of pulses of current, which will certainly be always in one direction, but by no means smooth or steady. A generator using many rotating coils would be needed to achieve this, as shown in figure 45. That is when the advantage of many coils. So it's not probably more electricity generated, but it's also, if it's here and here a wire, it's only coming when the wire passes. Here comes electricity, and again, only if one of the wires passes. But if there are thousands, then every time, basically all the time, a wire is, the electric field of the wire is crossing the electric field of a magnet and inducing electricity. Basically all the time electricity is generated. If there's just one coil, then there's current. If there's many, there's basically all the time someone giving current. From a single coil motor, a series of pulses, and then from a 4-coil motor, steady current with a slight rhythm, basically all the time. But it doesn't change much, but I don't understand the middle part or most part of it. I don't understand what we even want to tell us with this hand. The field direction. That is the field direction. That is something with magnets. So the magnets have a magnetic field. That is what we're talking about. And on one side is the north and the other side the south pole of the magnets. So the field direction is as given through the third finger. And how do we now know what direction it is? And the second finger is giving the current direction. No, the second finger is the middle finger. The first finger is the field direction. And the thumb is the motion. Why should we hold it like that? Your teacher might explain to you how you can arrive at this answer by using Lenz's law, mentioned earlier, but the argument is rather involved. Fleming's rule is easy to remember and to apply to any generator. If you look back to figure 40, I don't understand what the brushes or the slip rings are doing. As the coil rotates, a current is induced in it and is led away from the generating coil via two rings which rotate with the coil. These are called slip rings. So the slip rings are rotating with the coil. Pressed against these by springs. Springs are these things which go up and down. I don't know what springs are. Springs are these things which you can have it in a pen, with the pen goes on the cars with the things there, the wheels go in and down. Springs, I know what springs are. Wait a second, I know what springs are. So pressed against these by springs are blocks of carbon called brushes. I know it makes sense. These things here to the side, these are carbon brushes. Okay, there's a block of carbon, and that is pressed against it by springs, so it's all the time pushed against it, even if it's moving a bit. Pressed against these by springs are blocks of carbon called brushes. So the carbon block pushed against it is called brushes. They are pushed with a spring against it. And there's a slip ring that is rotating with the rotating coil. The current produced alternates at each side of the coil. As each side of the coil goes up through the magnetic field, then it turns down through it, and so on. So here is a simple alternating current generator, usually called an alternator. In practice, an alternator will have not one but many turns of wire in each coil and several coils, not merely one. You may remember what we said on page 44, that magnetic lines of force travel more easily in iron than in air, so you will appreciate why the coils of a generator are wound on an iron core. The kind of arrangement shown in figure 41 gives us some idea of how the magnetic circuit is arranged, so that the coils of wire move in a small air gap between the outer stationary part stator and the moving inner part rotor. The coils of wire move in a small air gap between the outer stationary part. So magnets. The coils of wire moves in a free gap out of air between the magnets. And the moving inner part, the rotator. I don't completely understand it. The rotating coil assembled is called the armature. And it is in the armature coil that the current is produced. There are three important points which arise in connection with generators which must be understood. Eddy currents. Not only do the coils of wire rotate in a magnetic field, but the core itself does so, and currents flow to and fro in the core, causing it to become hot, and of course to waste energy. These unwanted currents, called eddy currents, are kept small by making the core of thin strips of metal bolted together, so that each eddy current is quite small. What is an eddy current, and what means bolted together? Bolted together. Is this when you make metal hot and it comes in together? We will see later how this reduces the heat production. Alloys are chosen for the material of the core which are even more suitable than irons in their magnetic properties and having high permeability and low energy losses during the repeated changes in magnetic conditions. Now, I'm going to end with what I did already 2-3 times. We don't really understand it all, but we can follow. That was an electrical engineering part. If you are here for electrical engineering, you can go directly to the next part of electrical engineering. If you stay here and participate in the standing yoga, then it's a diagonals. The feet are standing together, you're breathing in and lifting the arms up. And all the arms down. The eagle to wings exercise, in and up. Out and down. Breathe in the arms up. And out open to the side. In and up. Out to the other side. In and up. Make an inch space between the feet and open again to the side. Breathe in, come up onto tiptoes. And breathe out and go a bit down. In and up. Out to the other side, down with the heels. In and up onto the heels. And out, sink again down. In and up. Out and the hands down onto the knees. Breathe again in. And out and make a hell with the bag. In into the middle. And out, make a valley with the bag. In into the middle. Out, make a valley. In into the middle. Out the valley. In into the middle. And out come slowly with the round back up and make it the top back with the shoulder up. Breathe in the arms up. And out come up on the tiptoes. Breathe in and reach high. And out, down the feet together, the down diving dolphin, down to the ground. And now the marmot. Breathe in and bend the right leg. And breathe out and stretch the left leg. In and change. Out, stretch the right leg. Legs again together. Straight down, both at the same time stretching. Breathe in, lift the right hand up to the sky. Breathe out, bend the left knee. Look over the right shoulder to the right hand. The penguin. The hand again in and down. Breathe in, lift the left hand up. And breathe out and look to the left hand up. Bend the right. In and down with the hand. Out and down. Make a hand with space between the feet. Shift the weight to the heels and breathe in and go down. The pelican. In and up. Breathe in and go down. And breathe out and go up. In and down. And out and up. Take hold on the elbows and gentle rock from side to side. Hands again onto the ground, feet together. Breathe in, come halfway up with a straight back into monkey half lift. And out and down. In, halfway up, straight back. Out and down. And breathe in, hands again up. Hands together, and down. And now the illusionistic down sitter. Toes to the outside. Ulnar and space between the heels. Breathe in, lift the arms up. Breathe out and sink down, almost into the garland pose. Bend the hands onto the ground and with the back up and roll slowly with the round back up and make it the top of the good shoulder. In with the hands up. Out, sink down. Hands onto the ground. Back up and roll slowly up. Backward shoulder. Have the feet standing together. Breathe and lift the arms up. Without lean back, draw the shoulder blades together, the crab in the morning. In and up with the hands. Out and down again. In and up. Fingers together and lean back, read in the wind. In into the middle. Out and back. In into the middle. Out, lean to the side, refer in the wind. In into the middle. Out to the other side. In into the middle. Intertwine the fingers. Reach high with screw. And breathe out, reach in front, hollow the back, the bone curl snake. In, hands up. Change the intertwining, breathe in, reach high. And breathe out, reach in front, hold the back. In and up. And out, lean with long arms back, the sky hugger. In and up. Out and again back. In and up. hands down. Breathe in the eagle's wings again. Out and down. Again, in and up. Out and down. And the cactus collecting its stings in the evening. Breathe in the hands up. Bring the hands to touch and now the hands down to hearts. It was a standing yoga. I thank you very much and until next time.